Good morning. My name's Marina Pelosi with Cypress Systems. We are a subsidiary of Cypress Semiconductor, which is one of the world's largest semiconductor manufacturers. Our reason for being is to create non-invasive retrofit solutions for commercial and light industrial customers. Today I'm going to talk specifically about the wireless pneumatic thermostat, which has really three objectives: improved operational control, auto DR, and energy efficiency in existing facilities. So this would not be applicable to new construction, but it's really for the existing building stock that we already have out there, which, believe it or not, is primarily, or 70% of our existing commercial buildings are pneumatically controlled, which means that to move the valves and the dampers to control the amount of air and the temperature of the air coming into a room, it's actually not an electric signal, it's compressed air that's sending the signal and making those things move. It's very reliable and solid, robust technology that is about 100 years old. So it's prevalent, it works, but it does not give any feedback. So you're sending compressed air out there, out to office spaces, and you're hoping that it's keeping the temperature. And really, you don't know in a pneumatically controlled building until somebody calls and says, guess what, I'm too hot or I'm too cold. And then you have to physically go out to the space and figure out what's going on. So our existing buildings are predominantly pneumatically controlled. The reason they haven't all come up to our modern digital era is that it's really expensive to pull out that existing control air and replace it with wiring. And it's disruptive to the occupants. It takes time, and for a lot of situations, let's say you've got asbestos, you really don't want to go through that abatement cost. So it's very much the cost and the disruption to the tenant is the barrier to sort of upgrading these existing buildings. So we developed the wireless pneumatic thermostat, which is really a hybrid. It keeps the pneumatic control that's behind the wall, so that all the control air that's going to the ducting behind the wall stays in place. The replacement of the thermostat is very simple. You take the existing pneumatic stat off the wall, there's control air behind there, those tubes are connected to the back of our new wireless pneumatic thermostat, and all that control air continues to operate the way it has for the last 20 or 30 years. But what we do at our stat is convert it from that analog information to digital and then wirelessly send it to a front end. So now when the building operator gets that call that they're too hot or too cold, they can pull it up on their computer, change the set points, look at what's been happening over the last day, 2 weeks, 4 months, and get an idea about what's going on in the space. They also have the ability not to have to wait for someone to complain, but they can be alarmed at the front end that says, hey, you want this space to be 70 degrees, but guess what, it's 78. And it will tell that operator that information ahead of time. So I'll just go through some of the features. Wirelessly, you can remote wireless set point control. So what does this mean? Let's say in this space, well, this isn't such a great example, but say you have two cubicles next to each other and one person wants it at 74 degrees and the other person wants it at 65. If they each have a thermostat, they may go ahead and put their thermostats at those settings. And all that means, no one's going to be comfortable. All it means is that the building is going to use more energy so that they're heating the air coming over this cubicle and cooling the air coming over this cubicle, but in fact, you're still going to be at 70 degrees and no one's happy, but you're using a lot more energy to get to that 70 degrees. So with this kind of remote zone control, you can now say, you know what, you can't go down to 65 at this desk and up to 75 at this desk. You're going to stick between 68 and 72. or whatever the policy is for the facility, now you have control on your pneumatic thermostats that you've never had before. Those kind of features expand. I won't spend too much time. I want to kind of get into some of the energy saving measures. But these are some of the features that are available. So you basically have digital-like control of your pneumatic system. Not only do you get energy savings and maintenance savings, but you get more comfortable and happier occupants. More higher productivity because they're comfortable, they're not freezing cold, they're not too hot, they're not on the phone complaining to the building operator, why isn't somebody up here helping me out? And then not only do you get more comfortable occupants, but your building operator is going to be a lot happier too, because instead of running out there with his equipment, starting from square one, once he gets that hot or cold call trying to figure out what's going on, he's got this information at his fingertips. So before he sends someone out to the space, he can do some troubleshooting at the front end. And what I mean by a front end is just information coming to a computer that he can pull up, he or she. So here are some of the savings elements with the wireless pneumatic thermostat: energy savings and maintenance savings. I'm going to cover maintenance savings because it's pretty quick. Because we trend, that is, record all of the temperatures, the set point temperature, actual space temperature, and the branch line pressure, which means the pressure of that control air going up to the damper or the valve, we can now automatically calibrate the thermostat, because those are the three elements you need to calibrate a thermostat. Those old pneumatic thermostats required someone to do it physically at this device itself, so obviously a lot of labor involved. That's a huge maintenance savings. The troubleshooting, because you can see that information historically, the historical operation, the troubleshooting and ongoing commissioning is enabled, and that saves a lot of time for improved operation. And then reduced tenant complaints. Again, that just ties into fewer trips out to the zone for your maintenance staff. Energy savings, so this is really where you get into the kWh savings. I mentioned about the two spaces next to each other trying to each get to different temperatures. That's what we call temperature set point policy. So instead of the space being able to say, I'm going to go to 65, you can now control the range that set point will go. So now you can say, I'm going to go, lowest you can go is 68 and the highest you can go is 72, or whatever the policy is in the building. But now you can set that parameter zone by zone. Retro commissioning savings, there's a lot of energy that is used to overcome poorly operating equipment. But often it's behind the walls or above the ceilings, and you don't really know it's not working properly. Well, now that you've got this data trended, you can start to see where equipment isn't working properly. So your retro commissioning, the savings from identifying those poorly operating equipment and making those repairs actually makes your building operate more efficiently. So you get kWh savings from that. And also gas. I don't want to leave out that too. So there's therm savings as well from your boiler operation. Night and weekend setback. Again, often, the way these buildings operate, you've got one big fan that might be cooling 3 floors. And without individual space control, if somebody comes in on the weekend and says, I want cooling, they have to start up that big fan, and it's actually cooling all 3 floors. Well, now that you have that individual zone control, you can schedule it so those dampers in the unoccupied spaces are closed, and you can then slow down your fan operation. You get significant savings from that. So that's the night and weekend setback. Deck static pressure. They're just ways to tie in the zone information into your building operation management system, so your fan and your chiller plant are running more efficiently and more directed right to the demand from the zone. And then, of course, we've got the dead band, so that's another energy efficiency saving.
Can you just mention, you said, what is it? Is it 300,000 square foot building? Where is this model? You said you did some Equus modeling. What's the context of this build? Where is this building?
Okay, so this is not just one building. This is an illustration of the various saving measures that can be implemented with the WPT. Not every building will be able to take advantage of every single one of these measures. We also go in, it gets a little bit more involved for the existing equipment that's in the building to determine how much energy savings they're going to benefit from. And I'm getting I'm getting a signal here that I got to move on. Click the mouse. All right. So we covered most of that. I'm going to go a little quicker. Auto DR, this is a 300,000 square foot building in Santa Clara. They wanted to participate in auto DR, auto demand response. That's where, I think everybody in this room knows, but I'll just quickly say, that's when the utility can send a signal to a facility and initiate a sequence of operations that reduces their energy consumption. Well, we can receive that signal directly into our controller and automatically change the set points of the space temperatures. So that's going to reduce your chiller plant operation and your fan as well. This building, the installation is so easy. Take the old stat off, put the new one on. You don't have to move the plants. You don't have to move the picture. It's like that. The cost, our biggest competitor is really full DDC, where you do all the wiring and everything. For this building, $875,000 was the quote for upgrading this building. With the WPT, it was $175,000. It would have taken 6 months to perform that work at this building. It took 8 days to put in the WPT system. So you can see that it's non-disruptive, very quick and easy to install, and you get the same benefits as full DDC. I'm going to go a little bit quicker. I know barriers to market entry really have a lot to do. We're a manufacturer. We're working with more and more partners, but as a new company, we are what we're seeing is we just put our equipment out there. Often contractors are used to quite inflated markups, so us controlling the end user's cost is a real challenge to us. So we're working to find closer partners that can install at a price that maintains the value proposition, if you will. Another barrier to entry for us is that some really sophisticated design engineers want to see very minute level of detail that you're not going to get with the WPT that you will for full DDC. So that's another, and they're not familiar with pneumatic control. So even though we provide the data, they don't necessarily know how to integrate with that with their sequence of operation. So it's a little bit of an adjustment of figuring out how to marry that pneumatic with digital. And then, of course, limited funds. Money's tied everywhere, so that's another barrier to entry for us. But a lot of people love the product. What I'm finding is it's mostly helping people find the resources to actually implement them and get it installed in their buildings. I think that about covers it. Anybody have any questions?
Over here. Okay. You talked about, this is kind of several parts to this question, or multiple questions. You talked about, just on your last point about the challenges with pneumatic. A lot of people, this is kind of an art, right? It's been, how to calibrate pneumatics has been always a challenge and requires some training, perhaps staff that may have been trained many years ago. Typically, you wouldn't have I guess younger staff that would be familiar with these systems. So the first instant, I guess, of anybody coming into a building is probably wanting to replace to DDC or wanting to do those sorts of bigger capital investments. But anyways, the point is, what is the market potential on these sorts of buildings, what's the stock look like based on your assessment? You mentioned cost, and so that kind of. And have you tapped into any of the IOU programs for this, and in what programs have you tapped in?
Okay, great. So I guess the first thing on the pneumatics, yes, it's absolutely true. Not everybody's familiar with how pneumatics work. However, what we find is that most of the buildings that have pneumatic control, the building operators are familiar, at least functionally. And some people really love pneumatics and think they're far superior to digital because of the reliability, the they're universally, their equipment can be used from a number of different manufacturers for pneumatics. Where DDC often, if you have this kind of controller, you've got to stick with this brand of equipment, and if somebody else comes up with a DDC device, you can't necessarily integrate it with your system. Where pneumatic doesn't really have that kind of exclusivity. You know, compressed air is compressed air, and most of those fittings all fit together. But the building operators tend to be familiar with pneumatics, and they're already calibrating, and really this is sort of a benefit to them. They really see it as, okay, this is a real improved operation. With regard to the IOUs, the market, we think the market is enormous. You know, the big controls companies, Honeywell, JCI, have really moved away from pneumatics sort of 20 years ago. All their new product development is geared toward DDC. They really think of pneumatics as a thing of the past. Well, the fact is that our existing buildings are holding on to them. In fact, that one case study I showed was a building built in 2000 with pneumatic controls. So I mean, a good delineation is buildings built before 85 are going to very likely be pneumatic controls. And after that, they are likely going to have some DDC. But often for cost reasons, even with some new construction, they put DDC to the fans in the chiller plant, but not necessarily out to the zone. So our WPT is able to kind of broaden that visibility out to the office spaces for a huge number of buildings are still pneumatic at the zone.
On that point, before you get to the utilities, what is your sweet spot? I mean, because obviously there's a fixed cost associated with your controls, your control module, or your EMS, if you will. This is not integrating into existing EMS systems, is it? So
there's 3 levels of operation and integration. One is just as a standalone, where our controller is controlling all of the stats and receiving their information, and you can plug in a monitor wherever that controller is located, usually in like a utility closet or something in the building, and you can go right to it and operate it and see all the stats. Second level is to actually connect it via a Cat5 cable, just to get an IP address for that device and put it on your intranet. And then any computer that's on your intranet can have that same visibility and control, no matter where they are physically located. Third level is actually integrating all the data from our controller into your EMS system, you know, Siemens Apogee, Johnson's Medisys, et cetera, an existing building automation system, and we do that seamlessly. We're a native BACnet device. So via BACnet over IP, we can pull all that data in. And that's how you can get fan savings and chiller plant savings using the information from the zones.
So you had mentioned that you either use IP addresses or wireless. What's your wireless protocol that you're using? Is it Zigbee
so we do not use a Zigbee system. We looked at Zigbee. It's really power intensive, and a big driving component for us in the design of the WPT was saving the battery life. So we designed it so that the two little batteries in there will last 3 to 5 years. It operates on one battery, but we have space for two, and the idea is to extend that life. We do have a notification on our front end that says, hey, your battery's going dead at this stat. So we let them know about that. So we have a proprietary wireless protocol that was developed by Cypress Semiconductor. It's the same protocol that's used in sort of 80 million devices around the globe. It's non-invasive, highly secured. Because we do intermittent bursts to get the information to the front end, it's not as though it's constantly taking up airspace. So we're even in critical use spaces such as hospitals and NASA Ames aerospace kind of facilities. But the controller uses an IP address to get it onto your intranet. But the communication from the thermostats to the controller is wireless. Yeah. Okay, so our technology is in a couple of incentive programs. The ETAP program, a federally funded program managed by Energy Solutions. That program has expanded, but nevertheless, for public facilities, the wireless pneumatic thermostat was one of the technologies that was approved in the program. That program pays 18 cents a kilowatt hour for the first year of kilowatt savings. However, we've pretty much maxed out that program. So I'm just illustrating how our technology participated in it, not so much that, hey, everybody get on board, because all those funds are pretty much accounted for. So the ETAP program, and then another one called Oakland Shines, which is a program specifically for commercial buildings in Oakland. Energy Solutions. No, yeah, for the California Energy Commission.
Yeah, so
So
go ahead.
that's Energy Solutions manages the ETAP program. Energy Technology Assistance Program. Federal money supports the program, but it's actually directed through the California Energy Commission, and Energy Solutions administers the program. And then the other one is Oakland Shines.
You repeat the question.
No.
You repeat the question, Marina. Sorry.
The wireless is on the proprietary protocol is just on the wireless part. The data is available via BACnet over IP, and it's a Windows-based system. You can get the data from the green box on any computer. It's an XP device. I mean, you can get the data. The data itself is not proprietary. It's simply the way that the thermostat communicates with the controller. And the reason we do that is because interference and security is so important to so many facilities that this is one way we can ensure that it's non-invasive and highly secure. Just the wireless part.
Yeah, I think you have a pretty elegant solution, quite frankly. But I think one of the issues that's going to be difficult for utilities is going to be able to, how do you anticipate, because of the number of variables, ambient temperatures, set points, number of thermostats, how do you actually anticipate the savings? Because our rebate programs are based on annualized savings, which is a projection. So that's an issue for you, and I don't know whether you want to do simulation or some other way to go around that, and whether that's even acceptable to us, I don't know, but that's an issue. Second comment I might have with your market barrier is that if you're having trouble because there isn't enough spread for the installers, okay?
Well, first you have to say what's enough.
Well,
You have to define that.
yeah,
So,
I'm just saying you listed that as a market barrier.
right.
I'm just suggesting that you just go vertical and bring it in-house and be turnkey. That's my suggestion to you. You probably need, pneumatics popping out the thermostats, connecting the hoses. That's relatively low-tech, I think. Probably setting up the communications is a little bit more difficult, and you probably have to have a little bit more higher skilled person do that. But I think you could probably do that in-house. So that's just my thoughts.
Thank you so much. So we have developed, and you're absolutely right, the savings calculations are complicated because there are so many variables and each building is going to be different. We have developed models that are used in some of these programs to estimate the savings, and they're pretty detailed. So, not every building is going to be able to take advantage of every one of those. I guess I can just suffice it to say we do recognize that. It is tricky. It's not as though one size fits all, but we have developed a constant air volume model and a variable air volume model that can be you can put in the parameters of your specific building, including the bin data for the location that the building operates, and come up and do the modeling. And so what would be the best way for us to get that kind of feedback from SoCal Edison? Because I'd love. Okay. Talk to him. Very good.
Okay.
You're him.
All right. I didn't hear the question, I'm sorry. So I've just been informed that, okay, we're done. Marina, thank you so much.
Okay, thank you.